everyone. This is module 7. In this module, we are going to discuss the delta modulation and its drawbacks. So in this module, we also discuss the DM transmitter section, receiver section, and its drawbacks. First, let us see the drawbacks of PCM. In PCM, we all know that the bandwidth is n is always greater than or equal to n into Fm. It is always greater than n into Fm. In where n is the number of bits grouped per sample. That means as the number of bits, the n value increase, automatically the bandwidth required for PCM will also increase. Because PCM transmits all the bits, all the sampled bits it will transmit irrespective of the redundancy. So in order to reduce the signaling rate and bandwidth in PCM system, delta modulation considers only 1 bit per quantizer and transmits only 1 bit per sample. That is the first advantage of delta modulation. And the second advantage is here the transmitter and receiver implementation of delta modulation is somewhat simple over PCM. And in this case, we are considering the step size as fixed for delta modulation. So that is why it is called as linear delta modulation. If the delta modulation, if the step size is variable, it is called as adaptive delta modulation. Now let us see the principle of DM. This delta modulation, what it will do, it will transmit only 1 bit per sample. That is, the present sample value is compared. For example, in the figure you can observe. Let us see this instant. This is one instant and this is its previous sample instant. You can observe that there is a rise in the magnitude of x of t. That is the analog signal. Because if you observe the current sample value with the past sample value, then there is a rise in the amplitude. If there is a rise in the amplitude of x of t, then the staircase waveform will increase the amplitude by delta. For example, here in this case you can observe the m of t falls from sample to sample. In the present sample, if the present sample amplitude is considered with the compared with the past sample amplitude, the present sample amplitude is less than the past sample amplitude. So here the staircase waveform response reduces by a factor of delta. So when when the present sample x of t is greater than the past sample value x cap of t, then the amplitude of u of t will rise by delta. For example, if x of t is less than x cap of t, then amplitude falls by delta. For example, if you observe that x of t is greater than x cap of t, then you will have an increase in the step size by a factor of delta. For example, if there is a rise in the staircase waveform by plus delta, then data bit 1 will be transmitted. If there is a fall in the step size, then data bit 0 will be transmitted. This is a main principle of delta modulation. Just it will compare x with x cap. If x is greater than x cap, u of t will rise by a factor of delta, data bit 1 will be transmitted. If x is less than x cap, u of t will reduce by a factor of delta and 0 bit will be transmitted. Let us see the DM transmitter section. Here you can consider that x of NTS as a present sample value and x cap of NTS as a past sample value. And this past sample value is stored in the accumulator section. Now the two inputs are applied to the comparator. This comparator takes the error between the present sample and past sample. If x is greater than x cap, error will be positive. So E is positive when x is greater than x cap and E is negative when x is less than x cap. For example, if x is greater than or equal to x cap, that is present sample is greater than or equal to the past sample, then error is positive. If error is positive, we already discussed that the 1 bit quantizer, what it will do, it will raise the magnitude by plus delta. And this plus delta is added with the past staircase waveform u of n-1 ts to produce the present sample version of staircase waveform, that is u of nts. For example, if x of nts is less than x cap of nts, then error is negative. Then b of nts is reduced by a factor of delta. Then u of n minus 1 ts minus delta is our u of nts. Here you can remember that u of nts is nothing but u represents the step size, which is the output of quantizer or input to the accumulator. U of NTS is a current sample version of the staircase response, and U of n minus 1 TS is past sample version of staircase response. U of n minus 1 TS plus or minus delta is our present sample approximation. That's what we have mentioned in the equation 1 and equation 2. So finally, what is B of NTS? It is the output of 1-bit quantizer. It can be mathematically expressed as delta into sine of E of NTS, where delta is a uniform step size in this linear delta modulation, and the sine of E of NTS, that sine depends on the magnitudes of x and x cap. The sine of NTS is plus positive when x of NTS is greater than or equal to x cap of NTS, and it is negative when x of NTS is less than x cap. So based on that, you can write B of NTS as plus delta when x is greater than or equal to x cap. At that instant, binary data bit 1 will be transmitted. For example, if B of NTS is minus delta, that is when x is less than x cap, then binary data bit 0 will be transmitted. So here you can see that the summer, this is the accumulator section data. U of NTS represents the, already we discussed, U of NTS represents the current or present sample approximation of staircase response, and U of n minus 1 TS represents the past sample approximation of staircase response, and B is nothing but the output of 1-bit quantizer. It can be either plus delta or minus delta based on x and x cap, relation between x and x cap. So here the U of NTS can be expressed as U of n minus 1 into TS plus or minus delta. So here you can observe the basic principle of, a DM transmitter. What is that? And we have to remember this for the examinations. When E of NTS is positive, when E of NTS will be positive, when current sample X is greater than or equal to past sample X cap of NTS, then E of error will be positive. When error is positive, 1-bit quantizer raises by plus delta. At that instant, data bit 1 will be transmitted. For example, when X is less than the past sample approximation, then E of NTS will be negative, and B of NTS, which is the output of 1-bit quantizer, is also minus delta. Then data bit 0 will be transmitted. This is the DM transmitter principle. And coming to the delta modulation receiver section, here you can see an accumulator followed by low pass filter. Here the input is applied to the accumulator section. What is the input to the DM receiver? A binary stream. For example, let us assume this as some binary stream 1010. It consists of a sequence of binary bits, binary data. For example, if the upcoming bit is 1, then this summer, you can see here the accumulator, what it will do, it will add plus delta to the U of n minus 1 TS. U of n minus 1 TS can be obtained from the accumulator section, that is from the delay, that is acts as a delay element. So our intention is to get the staircase response. This can be observed, this can be attained by adding either plus or minus delta to U of n minus 1 TS. U of n minus 1 TS can be obtained from the delay element. And here we will take plus delta when the data bit is 1, and minus delta when the upcoming data bit is 0. The completely here the plus or minus delta, here the addition or subtraction depends on the upcoming bit. If the upcoming bit P of NTS is 1, then accumulator directly adds plus delta to u of n minus 1 ts. Otherwise, it will subtract delta from the u of n minus 1 ts. So finally, we will get the staircase response, which will be smoothened by the low pass filter. Here you can see low pass filter. So DM receiver consists of accumulator and low pass filter. And for DM receiver, you have to remember this one. U of NTS is U of n minus 1 TS plus or minus delta, plus delta when upcoming data bit is 1, minus delta when upcoming data bit is 0. With this, we can conclude the DM transmitter and receiver sections. In the next class, we can continue with the drawbacks of delta modulation as well as the SNR calculation. Thank you for listening.